Alrighty, it's lecture number 5. We're gonna count sig figs and then do some math. All right, so first things first, like when you're looking at a number, one of the things you have to do in class will be just, I give you a number and you tell me how many sig figs there are. So, what digits are significant? What are not significant? Really easy. If it's not a 0, it's significant. All right, so anything that's non-zero, all non-zero integers always count as sig figs. So 3,456, 4 sig figs. Very easy. All right, now let's get to the zeros. All right, so zeros are a little funkier. There's 3 classes of zeros, actually. There's leading zeros, there's captive zeros, and there's trailing zeros. So let's talk about the leading zeros first. Leading zeros are zeros that are on the left-hand side of your number. So if I had 0, 0, 0, 0, 0, 0.0000, and then the number started, like all those things are leading zeros. And leading zeros never, ever, ever count. So leading zeros don't count. So 0.048 only has 2 sig figs. It's just the 4 and the 8. The next class of zeros are the captive zeros. And just like the name implies, they are captive. They're trapped inside the number, kind of sandwiched in there. So 16.07, that 0 counts. So captive zeros always count. So leading zeros never count. Captive zeros always count. And the last class of zeros we have are the trailing zeros. So the zeros that come after your number are called trailing zeros. Zeros that are on the right-hand side of your number. So 9.300 or 150. Like those are the trailing zeros. The trailing zeros will only count if there's a decimal point. So this is like the weird class because sometimes trailing zeros count, sometimes they don't count. It depends on if there's a decimal point in the number. So 9.300 has 4 sig figs, but 150 with no decimal point there only has 2 sig figs, the 1 and the 5. If I put a decimal point right here, now it has 3 sig figs. Then that would count. Then that trailing zero would count. All right. So that's the deal with that. The other thing I want to tell you about is exact numbers. An exact number, well, it's exact. So it has an infinite number of sig figs. You can think of it as like 1.000 infinite zeros. It's like 1 inch exactly equals 2.540000 infinite zeros. Centimeters exactly. Or if I count pencils, like if I got 9 pencils and I counted them, it's not like it's 9 plus or minus 3. Like I know how to count. And even if I got hit in the head by a brick, I'd still be able to count 9 pencils. I'd be like, okay, I got 9 pencils. So it's exact. The other thing that counts as exact would be your conversion factors. So conversion factors aren't going to change your sig figs because by definition, there's 100 centimeters in 1 meter. There's 1,000 milliliters in a liter. Those are exact things. Right, so those don't mess up your sig figs. All right, now let's talk about doing some math. All right, so there's actually only a couple rules. There's a rule for multiplication and division, and then there's a rule for adding and subtracting. All right, if you're multiplying or dividing, right, your answer can have no more sig figs than the number you started out with that had the least amount of sig figs. So that's a little different than what the text is saying right here. All right, but I think it's just easier to look at an example. So 1.342, that has 4 sig figs. 5.5, that has 2 sig figs. Now you can just put this in your calculator, that's fine. We'll say 7.381. All right, but my answer can have no more than 2 sig figs. All right, because my number that I started out with the least amount of sig figs, that's what determines how many sig figs are in my answer. So this one only had 2, my answer can only have 2. All right, if I had 50 sig figs in the first number and then 3 sig figs in the second number, right, I would have 3 sig figs in my answer. Right. So it's whatever your least number of significant digits are, that's what you'd go with on multiplication division. Cool. All right, so 2, boom, answer's got to have 2. So you're going to have to round the thing. So 7.381, you're going to round that so it has 2 sig figs. All right, so 3 goes up because there's an 8 there. Boom, gets clicked up there. What else we got? Adding or subtracting. This is a little bit different. Basically, when you're adding or subtracting, your answer can be no more precise than your least precise number. And your least precise number is going to be the number that goes out to the least number of decimal places. So if I were to add up 23.445 plus 7.83, just plop that in a calculator. It's going to say 31.275. But because this number stops at the second decimal place, right, my answer can't go past the second decimal place. All right, so even though this one goes further out, I can't go past the second decimal place. All right, that's the rule. So when you're adding or subtracting, your answer is no more precise than your least precise number. So you take this 31.275 and you would round it appropriately to 31.28. And that's that. And just so you know, for class, if I'm asking you a sig fig problem, yes, I'm going to be kind of nitpicky on sig figs, but over the entire course, I want you to like try for proper sig figs, but I'll have a little bit of leniency. I'll teach it. I'll treat it like the AP graders do. If it's plus or minus a digit, it's okay. So if the answer should have been 31.28 and you gave me 31.275, I would let that slide. All right, but if you gave me 31.275, 86923 and had this gigantic trailing number, then I'd probably knock a couple points off of that. All right, there you go. Catch you in the next one. See ya.